So now that we're done with this, we're ready to do the twist, and by that I mean the twisting of the spine around its vertical axis. First of all, you will notice I renamed my expression nodes to something a little bit more meaningful. So they're called expression spine joint move 1. I skipped the underscore C underscore in this case because I mean the spine is still in the center, so I guess I could have done without that in some of the other nodes, but I just did it for these. It's not a big deal. So we're ready to do the twist of the spine, and by that I mean the following. If I grab my my controls and I rotate them this way, you can see that our spine right now has this very nice curvature to it, and that's pretty good. Same if I rotate it on X. You can see there's flipping of the head right now, but that we don't have to worry about that part at this moment. Now the only thing that is left to do is to get the spine to twist like this. You'll say, well, I already see it happening. Yeah, but it's not doing exactly what I want, and there's these other strange rotations happening in other parts of the spine itself, and so we need to fix that too. There's one thing that is important to know about specifically with spines, and that is the order of rotations is extremely important, because the movement of the spine of the character is going to be very free. So if the order of rotations is not set properly for the controls, there are certain poses that are going to be very hard to achieve. So what you want to see is, let's take for example our shoulder control. If my character turns to the left, I want to still be able to move his shoulders to tilt them in a direction, or I want him to be bending forward or backwards. So why do I say that order of rotations is important? Well, because in this case, for my control, which is oriented in world space, Y is pointing upwards, then I want that as I rotate on that axis, my other two axes should follow. And for that to happen, Y needs to be the first axis evaluated in the rotation. That way, my other two axes are going to follow, and I can use them after a rotation on Y has happened. If I don't use that rotation order, then it's going to be very hard for me to get the rest of the rotations on the torso working correctly. What I mean by that is the following. Let's go to the channel list, and I'm going to add a rotation channel to this control because it doesn't have one yet. And when you do that, you will see that the order of rotations appears over there. I'm actually going to do that. If you don't see it, it's because your item does not have yet a rotation transform. So you have to go in and add it manually. These are only added when Modo figures out you moved or rotated something. So once you have rotated an object, or you add manually the transform channels, you see this order of rotation drop down. And right now it's set to ZXY. And we've talked about this before in other videos, but I'm going to recap what we said in the context of the rotations of the spine. Since we are rotating on the y-axis and I want the other two axes to follow, then y needs to be the first axis evaluated for the rotation. And that is the last axis in the order of rotations. So in this case, y over here is fine. The ZXY order of rotations is good for what we're trying to do. In some other applications, the default tends to be XYZ. So if this is what I would have, let me show you what would happen. As I rotate on Y, the Z-axis is not coming along with the rotation. It's staying there because it's evaluated before Y. So it cannot update according to the rotations on Y, only X can. And now I have this really bad problem where I cannot rotate on Z anymore. Because I have this, I'm approaching gimbal lock. If you go to local rotations, then yes, you can rotate on Z, but you have to remember that this is going to generate not one curve of rotation, but two. So this is a problem. This you cannot use. I'm going to go back. And so you need to use a rotation that has y at the end of the order. So we can use zxy or xzy. In this case, I'm going to stick to the Modo default, which is zxy. And that way, when I twist on y, my other two axes are parallel to and stay aligned with that rotation, which is what I want. So you want to make sure that all of your torso controls are set up that way. Okay, let's add a rotation transform for this guy. Here's the ZXY order. This is Modo's default, which can be changed in the preferences dialog, but honestly, I don't see any reason to change it. So now that we've talked about that, how are we going to drive the rotations on all these guys to work the way they would with these controls? Well, our path constraint for any of these objects, let's find one here, has this roll channel, and as I manipulate that, you can see that the joint is rotating on itself on the y-axis. So that's what we're going to use to do the twisting of the spine. And to have a good reference for that, I'm going to create some references boxes that I can use to see that my twisting is happening properly. So these are just going to be basically cubes that I'm going to move over to different parts of the spine. So let's create one here. And I'm going to select all the polygons and scale them down. And let's, I'm going to align it. I'm going to match it to my first joint. There we go. And I'm going to take again all the polygons and move them up. Oops. Well, I don't care too much about the actual careful positioning of this at this point. And now I'm going to duplicate it and match with the next joint. Duplicate, match with the next joint. And I'll just keep on going, one per each joint on the spine. And the last one, I think, yeah. So there we are. Okay, now I'm gonna give them a better shape because I'm not gonna be able to read rotations on these guys the way they are right now. So let's scale them like so. I'll do the next one. I'm gonna build sort of like a torso looking shape of sorts. And actually you will see that there's quite a few rigs that use something like this, so we're gonna do a much better version of this later on, which is called a cut res rig. For now, I just want to get some visual reference of how the changes I'm going to be doing on the spine are going to affect the mesh or stuff like that. So let's say that's our torso. All right, so we need to wire some values onto the roll channels of the constraints. So let's just do that now. I'm going to grab both of our controls. I don't think they are part of the schematic yet. So let's bring them in. And we're going to be using this to drive the roll value and the constraints. And let's zero them out. Let's make sure they're zeroed out. Okay, he's fine, and he's fine. Perfect. Right. So how's this going to work? Well, the first thing is I need the roll channels on the nodes themselves. Let's bring this up because it's not there. So I'm going to select all my constraint nodes, right click and say add channel role. So they all get the role channel added. I'm just going to lay out this a little bit better. I know, I'm a stickler for cleanliness and order. I will not have chaos in my rigs. Anyway, so there we have our role channels. Fine. So what we need to do, what I want the rig to do is when I rotate the upper control, the joint on the top should rotate with it, and then that rotation should go down as I as the value is going down the rig. And I want the same to happen to this with this control over here. As I rotate this one, I want the bottom joint to rotate with it, and that rotation should continue all the way up the spine, but decaying as it goes up. So we're going to be using a very similar system to what we did over here with these values. Okay, so let's move this over a little bit, and we're going to, what we're going to do is we're going to take the rotation of one of these guys, and we're going to multiply it by these values over here. Okay, and then we're going to take the rotation of the other guy and multiply it by the same value but on the opposite direction. We're going to add both, and we're going to plug those into the role values for each constraint. So let's see how that's going to work. We're going to start from the bottom this time. So this is the shoulders control, and actually let's move him over here. Well, I'll do that later because I'm going to need them together to plug the values without panning too much on my view. And let's add math multiply node, duplicate it, and now a math add, and add those together. So what am I multiplying? Okay, I'm gonna multiply the rotation of the shoulders, and in this case I need to add those channels to the nodes too, by the index of the object itself. So let's add first our channels. Let's go to the channel list, and these guys have to rotate on Y. Okay, that's the axis that we're going to be rotating to get the twist going. So I'm going to add the Y rotation to my node, and same for this guy. Fine, so now we have, let's start with the hips. I'm going to multiply this, yeah, it's just Y, perfect. Multiply that, oops, by, since this is the bottom joint that I'm about to wire, it needs to follow the hips perfectly, okay? So I'm going to multiply it by 1, which is my index over here. I call them index, but well, they're just basically the weighted positions of normalized positions of the joints along the curve. Then I need to take the rotation on Y from the shoulders and multiply that by 0. Why? Because I don't want the bottom joint to be influenced by the rotation of the shoulders at all. So I'm going to leave it like this. This is a 0 multiplication. I add both. Should be in, yeah, let's enter setup mode. And I just wire this to the roll value of the first joint. Okay, and that's all we have to do. We have to do this for every joint. So let's see how this would work with other joints. Well, we can test this first by taking our bottom control and rotating it on Y. And you can see the joint rotating. My boxes are not, but that's because they're not linked to the joints yet. And actually we could do that now, so to help us see what's going on. So I'm gonna take the first box and just parent it to compensation to its respective joint. Let's do that very quickly. There you go. Okay, let's continue with our setup here. And I'm going to take these nodes, duplicate them. So I'm going to disconnect all their sockets because we don't need those. And let's do the roll for the next constraint. And this one is going to be the same thing. I take the rotation of the bottom control, but this time instead of multiplying it by 1, I go to the next weighted value, which is 0.83. So I want to multiply that rotation by this amount, and now I take the rotation of the shoulders, and I multiply that not by 0, but the upwards going next position, which is 0.17. Those two are added, and I plug that into the roll value. I forgot it's safer to do these things always in setup mode. So there you go. Let's see how that works. If I take this guy and rotate, you can see the difference right there. You can see that the bottom box is following my control perfectly, while the next one upwards is rotating a little bit less. So that's the effect we want to have throughout the entire spine. Okay, so we're going to continue wiring this. Let's take the next set. Let's duplicate these guys. You can use these or the ones above. It doesn't matter. Let's rearrange them a little bit. And we need to unplug this connection. Alright, so we have already wired the hips and shoulders control, so we go to the next set of values. So the next one for hips is going to be 0.67, and the next one for the shoulders is going to be 0.33. There we go. And plug that to our roll amount, like so. And we just keep going. Let's move this guy over here. Duplicate those. Move over here. Again, you could do this with an expression, as I demonstrated earlier, if you prefer to avoid having so many nodes. But in this case, it's such a simple set of operations that it doesn't really matter too much. And now these values have to be both 0.5. So this guy 0.5 and 0.5. So we are at the exact middle of the spine. Oops, I'm not at the right spot. It's here. Okay. We need to keep going. Let's see. Duplicate those. Let's move this guy over here, this guy over there, this guy over here. And now we need to use, we're going up to the towards the upper parts of the spine. So now we're diminishing the effect of the hips control and increasing the effect of the shoulders. So for hips, now we are down to 0.33. And for shoulders, we're going to be using 0.67. Okay, now For our hip, we're down to 0.17. For the shoulders, we're up to 0.83. Roll. And the last one, needs to be 0 for the hips control and 1 for the shoulders control, and we plug that onto the roll value. And let's take a look. We take our topmost control, rotate it, it rotates nicely. Bottom, yeah, that's looking good. So we've got the roll already wired. We have nice spine twisting. This sort of completes the setup for the spine. Now we have everything that we need. There's still some stuff that we need to fix, and we need to package the spine nicely, and we need to support other things that we're going to be doing later on. But for now, we've already have this spline IK functionality that we were looking for. This is what we wanted. We now have the ability to twist the spine along either position in space, like we can twist it from the top, from the bottom. We can stretch it or not. We need to get out of setup mode. Okay, we have all that stuff going, and it's all nice. We still need more control over the spine, but right now we have our spline IK setup. We now have to build the FK setup that we're going to use to control this IK setup, and we need to start looking at packaging the spine and some other little things that we're going to have to solve. So we're going to do that in the next videos. Okay, let's get started on the FK spine. The FK spine is going to be a totally separate hierarchy from what we've built so far, and the reason is this FK spine is going to be actually a layer that is going to drive the pseudo IK spline setup we just did. It's not going to be a matter of blending between both. The actual animation system for the spine is going to work on both, but the purpose is to use the FK spine to mainly rotate the torso into its correct pose, and then use the IK spine for additional rotations on top of the AK spine. FK, sorry. So let me show you how that's going to work. First, we need a totally different hierarchy for our FK spine, and it's going to be hierarchy made up of 4 locators running from the base of the torso all the way up to the base of the neck. So the way we're going to set it up is let's create first 4 locators. There we go. 1, 2, 3, 4. There you go. And I'm going to create the hierarchy with them just immediately. Let's drag 4 onto 3, 3 onto 2, 2 onto the first one, and now we have a hierarchy of locators. And I'm going to place the first locator here at the base of the spine. Now, the reason I cannot just go ahead and match this locator onto this joint is the following. This joint has the orientation of the joints on the spine, on the bone system. Well, bone system, I call it the bone system, but all these joints have this orientation where X is running down their length, okay? But our controls that we're using for animation are using world orientation, so they're pointing up on Y. If I go and match the orientation on these guys, I'm gonna end up with 2 different orientations for my animation controls, and that's not really good because it's going to force the animator to use 2 total different systems for animation. So he's gonna have a set of function curves for the IK controls and a different set for the FK controls, and that's going to be hard to manage. So we want to have exactly the same rotations happening for both sets of controls. So what we need to do is to have our hierarchy at this location, but on world orientation. And I just want to match the little angle that we have here so we can slant our hierarchy towards pointing T towards the end of the spine. We're going to do that by using an additional locator that I'm going to use temporarily to get that orientation. So let's create another locator, and I am going to match that guy over to this item over here. I don't care if the rotation right now, it's not the one I want. And what I'm going to do is add the object that I'm pointing to, turn off compensation, and I'm going to add a direction constraint. So as you can see right now, it switched orientations because the constraint is using a z-axis, and now it's pointing down on z. But I know I want y, because y is the axis that is used to point up in world orientation. And I can see that x is pointing in the right direction. These are my world axes right here, x and z. So it's already pointing in the direction that I want. Now I can take my first locator and directly match it onto the new locator that I just created, and I'm gonna get the orientation I need. Okay, so now that we have that, I can get rid of the locator I used for the constraint. We don't need him anymore, and I can just proceed to space my locators evenly all the way up to the base of the neck. So how am I gonna do that? Well, there's actually a very easy way to do this, and we're kind of set up to take advantage of it. Let's go to my schematic. What I need to do is know what the distance is between this object and this object, and then divide that by the number of segments that I need. In this case, it's 3. So we can see that these objects are already in the schematic view. So I'm just going to go and measure the distance between them. And I'm going to do that using a measure distance node. So I'm going to create the node, and I'm going to plug one node's world position as a position from, and the second item's world position as a position to. And I'm going to check on the channel list. There's the distance output channel right here, and it's telling me the distance is 420.6 millimeters. So let's do 420.6 divided by 3. That's 140.2. This is the distance that there needs to be in between each locator. So let's just move them 140.2 units. Let's go to the second locator, and we're going to enter on its y-axis 140.2 millimeters. Then we take locator 3, 140.2, and locator 4, 140.2. We're done. That's what we need. Let's now change the shape on these guys. Let's select them, and I'm going to make them onto nice spheres and resize them accordingly, something like that, and also change their color. Let's make them like a sort of like a deep blue, like that. That's okay. And let's also rename them. This guy is going to be okay, he's not letting me rename here, so rig center FK spine start, and this guy is going to be rig center FK spine end, and the two in the middle are actually going to be controls that we're going to be using to animate with. So this guy's going to be control center FK spine lower, and this guy is going to be control center FK spine upper. Okay, and we're gonna take them all and zero out their transforms. Now they're zeroed, and we are going to change the shape on the two middle ones that are controls to something that the animator can better select. And to have a good idea what that would be, I'm gonna unhide the geometry. So let's start with the lower one, and we're gonna turn him into a circle facing up Y, and let's make him bigger. Yeah, kind of like so. And because of the arc at the back of the character, I can move this forward too. I think something like that is okay. Let's take the next one. Same thing. Circle on Y, and let's make him bigger. Yeah, that's pretty much okay. You want to make your controls usually easy to select, but not obtrusive either. And lastly, let's change their color to something that reflects more that they're controls. We're going to use a light blue like our other FK controls. That's good. They get a little bit lost with the uniform, but we can change the colors later on. So this is our FK spine, and the way it works is you would grab this control and use it to rotate the lower torso. Then you can go to the next one, rotate the upper torso, and so on. Now what we need to do is connect the IK spine to this new rig, okay? And to do that, we're going to use the controls that we already have, and they're going to be connected to the FK spine because these guys already drive the IK spine pretty well. But in order to keep the ability of these guys to be animated separately, I cannot just connect these guys directly to the FK spine. I'm going to add a couple of other locators on top of these that are going to be the connection point. So let's do that. Create a couple of locators, and I'm going to call the first one Constraint Center Shoulders Control, and the next one is going to be Constraint Center Hips Control. And we're going to match them to their corresponding controls. So the shoulders constraint goes to the shoulders control, the hips constraint to the hips control. And I'm going to parent the controls over to these objects. Let's go back to setup mode. I'm going to take the control shoulders, make it a child of the constraint shoulders, and control hips, make it a child of constraint hips. Okay. And now I can do my constraint. I'm just going to first resize these guys, make them smaller. So what I'm going to do is constraint these guys to the ends of the FK spine. Okay, so that way they will react to how the FK spine is behaving. So I'm going to take the constraint shoulders control and constrain it to the spine end on both position and rotation. So position and rotation, obviously with compensation on, because we know that both systems are using a different orientation. And then we'll take the hips constraint and constrain it to spine start and position and rotation. So what that gives us is when I take one of the FK controls, as you can see, it's affecting the upper spine portion, including the IK or pseudo IK control. So now I can affect the entire spine using this control. Well, either control, because I can use both. So that's it. That's how the FK spine works. Now, you might have noticed that we have some funky rotations going on over there with the joints, but that's a problem that we're going to look into to see what's going on and obviously how to solve it in the next video. So for now, this is our IK spine setup. It's working. Let's continue. All right, let's take a look at some of the problems that we're going to have with the current setup. If I take my group and move it around, you will notice this. You will notice that the controls are following the group, but this part of the torso is just like flying off. And what's happening is these joints are moving twice as much as you're moving the torso group item. And what's going on here is what's called a double transform. So a double transform happens when an item is receiving transforms from two different places. And usually the first transform that you will always see a item receive is its inherited transforms coming from its parents. You'll remember that when we talked about hierarchies in the earlier videos, we were talking about the inheritance of transforms, how child nodes inherit the transformations of their parents. So that is usually the first source of movement in a hierarchy, which is what you see with the control objects over here. However, what's going on over here is we have those inherited transforms too, because everything is part of the hierarchy under the group torso. But there's also very likely something deforming one of the objects over there, and that's why you see a double transform. Whenever you get double transforms in a hierarchy, you have to check because usually there's inherited transforms acting with deformers, and then you get a double transform. So in this case, it's not really that hard to know which object is the affected one, because amongst all the objects that we have over here, there's only one that is being deformed, and that's our curve object. Our curve item over here, remember, it's under the influence of these two weight containers, which are being used by some transform effectors. Well, some transform deformers that are using a locator to move, which are these guys over here, etc. So that's what's happening. Our curve is receiving the deformations that allow us to deform the torso, and it's also receiving transforms from the group torso item. So we need to get rid of one of those, and obviously we cannot do that with the deformer because we need the deformer to work. So what we're going to do is turn off the transforms inheritance for the curve. So let's select the IK curve we made, and if we go to the channel list, you will notice that for every item in Modo, the channel list always has these inherit channels over here. And there's three. There's inherit position, inherit rotation, and inherit scale. So these channels allow the object to receive transforms from its parents. And this is what's happening right now. So all I'm going to do is turn them off by clicking on each channel. And you will see that the curve goes back to 0. It's because it's not inherited in the position anymore of the transforms of the torso group. So what we need to do is select the curve and match it back to the base of the rig. Any of the objects at the base of the rig will do. And now you'll see it fly up. So let's bring it back down by zeroing out all its channels. And now it's moved back into position. So that takes care of that. And let's see what happens now when we move our group control. No more double transforms. Everything is moving the way it should. Okay, so this takes care of the double transform problem. And again, if you ever in your rigs face a situation where you're getting objects that are being double transformed, check how they are being affected by either a hierarchy or also deformers. Sometimes there might be also channels in the schematic affecting them. So all these things are things we need to keep in mind. And what I'm going to do now is in the next video, we're going to take a look at what's going on with this strange twisting problem.